Today's lesson is over algebraic relationship given the relationship or function rule. You are given the input and then you need to find the rule to turn it into an output number. So in other words, you're given the independent variable, you find a relationship rule, and then you're able to find a dependent variable. The lucky dragons that live in Enchanted Forest weigh 4 times an x, which I don't know what x represents. X is a variable, is a symbol that represents a number. When they are x years old. Oh, x is the age. Make a table of values show the weights of 6-year-old, 8-year-old, and 10-year-old. So age is x, and then this is weight. So when the dragons are 6, 8, and 10, when they are 6 years old, we multiply that by 4, so they are 24 pounds. When the dragon is 8 years old, we multiply by 4, they are 32 pounds. When a dragon is 10 years old, we multiply by 4, they are 40 pounds. So the relationship rule is multiply by 4, or 4 groups of the age. So if you know the age, you multiply by 4, you'll be able to find the weight. So the rule 3x, where x is her brother's ticket, can be used to find Jamie's number of tickets. Make a table to identify the number of tickets Jamie has when her brother has 40, 50, and 60 tickets. Then graph it. So if her brother has 40, 50, and 60, that represent x, that's the number of tickets he has. The relationship is 3 times x. What number is x again? X is the number of tickets the brother has. So it's 3 times the number of tickets Jamie's brother has 40 is 120 tickets Jamie has. 3 times 50 is 150 tickets that Jamie has. 3 times 60 is 180 tickets that Jamie has. So let's graph it. If Jamie's brother has 40, Jamie has 120. If Jamie's brother has 50, the sister has 150. If Jamie's brother has 60, the girl has 180. If you graph it, you can tell there is a constant rate of change. It's constantly changing. It's a fixed amount. It seems like it is changing. Every 10 tickets that Jamie's brother has, it goes up by 30. So Jamie's ticket is 30 tickets for every 10 tickets that the brother, or another way to say it is for every 3 tickets that Jamie has, the brother has 1. So let's answer this question. List the independent and dependent. Dry mix. You learned this from science. What is dry mix again? Dry mix means dependent is the y-axis. Independent is the x-axis. So list the independent. Independent is dependent. Independent is Jamie's brother tickets, and the numbers used for Jamie's brother tickets are 40, 50, and 60. List the dependent variable. The dependent variables are Jamie's tickets, the girl's tickets. Her numbers were 120, 150, 180. Write a statement explaining the relationship. Well, the relationship is this. If you go back and look at this table, Jamie always has 3 times more tickets than her brother. If you look at the graph, for every 3 tickets she has, her brother has 1. So the relationship is Jamie has 3 times more tickets than her brother. We're going to be reading a story called Miss Nelson, and in this story there are a lot of bad kids who do bad deeds when Miss Nelson is missing. For example, one bad kid would do 13 bad things, like spitballs. 2 bad kids will do 26 bad things, such as throwing a tantrum. 3 bad kids would do bad things like, I don't know, yelling at the teacher. So What is the relationship rule from bad kids to bad deeds? It's multiply by 13. So, if there are 8 kids on this table, how many bad deeds would it do? 8 times 13 is 104 bad deeds. If, according to the table, how many bad deeds would 10 kids do? If there are 10 bad kids, we know the relationship rule is multiplied by 13. There'll be 130 bad deeds. Count the number of kids. All right, we're not going to that because we don't have a class here. List the independent and dependent. List the independent variable in the table. Independent. Let's see. Dry mix. The independent is the x value. So x and y. So this would be the independent. This would be the dependent. Let's think about it. The number of bad behavior depends on how many kids there are. If there are more bad behavior, it's because there are more kids. And there's less bad behavior because there's less kids. So it depends on how many kids there are. That's how another way you could do it. Know which one's the independent and dependent variable without using dry mix. So the question is, what is the independent? The independent is number of bad kids. Number of bad kids. What quantities did I use? I used 1, 2, and 3. Which variable numbers and it represents the dependent? Dependent is the number of bad deeds. And the numbers were 13, 26, and 39. Write an expression to show the relationship between K and B. So kids, we multiply it by 13. So the relationship is K times 13, or 13 groups of K. There's 13 bad behavior per kid. So what we're going to be learning is the sequences. Sequences is like a pattern. Sometimes in a pattern you either add or subtract, or you multiply or divide. If it's all adding, it's called arithmetic. If it's all multiplying a pattern, then it's called geometric. For example, in here you're adding 8 to each term. In this one, you're multiplying 3 by each term. So one is arithmetic and geometric. You don't really need to know that per se, but it's good to know that there are patterns of adding and multiplying. Sometimes there's dividing and subtracting. So use words simple to describe the real value of each term in relation to its position to find the value of the 9th term. The position is 3. What's the value term? I believe it's plus 8. Plus 8. Plus 8. Plus 8. So, so you add 8 to the position. If I had to find the 9th term, 9 plus 8 is 17. What's the relationship? Position's 5, and I want to find its value, 45. 6 to 54, 7 to 63. The relationship, I believe, is times 9. Times 9. Times 9. 9. If I want to find the 9th position, 9 times 9, the value will be 81. With a partner, decide on independent, dependent, and expression. So again, well, first let's find a relationship rule. I start with -1, now I have 3. I start with 0, I have 0 still. I start with 1 to -3 and 2 to -6. Well, it's not plus or minus anything. Maybe it's a multiply. Because anytime you multiply 0, it would be 0. Let's go here. Let's start with the easiest one. 1 times -3 is -3. 2 times 2 groups of -3 is -6. Oh, it's times -3. So what's the independent dependent? Let's see. Dry mix. So independent is the x1. So this is the independent. And this is the dependent. So the independent is y. The independent variable is x. The dependent is y. The expression rule is x. What do I do to x? I do x times -3 or -3 groups of x. Cups of sugar S. Relationship rule, dozen cookies C. You know what? I'm not going to work with that. I'm going to go look at the integers, the whole numbers. It's times 4. Is it really times 4? Let's see. 3/4 times 4 is 12/4 or 3. It is times 4. So relationship rule is times 4. So dry mix. The independent is the X, so it's this one. This is the independent. So it's cups of sugar, and the dependent is dozen of cookies. Why is this again the dependent if you do not know your dry mix? The dozen of cookie depends on how many sugar you have. So, expression rule, you're multiplying by 4 the number of cup of sugar, so S, or 4S. Miles driven, relationship rule, gallons used. So what's the relationship here? Well, it's getting really large, so I think it's multiplying. So what do I multiply 115 by to get 116.5? Let's go see. 2, 3 groups. 3 groups. I multiply by 23 and 3/10. So what is the dry mix? Let's see, independent is X, so this one, because this is X and Y. So this is the independent, miles driven. The dependent is gallons used. Why again? If you do not know your dry mix, the number of gallons you use depends on how many miles you drive. The more you drive, the more gallons you use. The less you drive, the less gallons you use. What is the expression rule? You're multiplying the number of miles, M, by 23.3 or 23.3 M. Number of weeks, relationship growth, independent. I'm going to look at the whole numbers. It seems like it's getting smaller. Oh, subtract 1. No, that doesn't work here. Divide by 2. Another way to say it is times it by half. So which one is the dependent and which is the independent? Independent is X, X and Y. So number of weeks, dependent is growth. So what's the thing? You're dividing the number of weeks by 2. So what letter do they use? W divided by 2. Another way to show it is this one. W divided by 2. Is how do you write this as a fraction? W divided by 2. And next one, slices relationship. If you buy 2 slices, it will cost you $3.50. If you buy 4 slices, it will cost you $7. If you buy 6 slices, it will cost you $10.50. So each slice will cost $1.75. So you're multiplying $1.75. So this is X, this is Y. If there were no letters there. So the independent of dry mix. Well, let's think about it. The dependent is what depends. The total cost depends on how many slices. So total cost must be the dependent, and the slices must be the independent. If you don't really trust me, dependent is the y-axis, so it's going to be this one. So what's the rule? You're multiplying the number of slices by $1.75 or $1.75. So what we talked about today is, again, focusing more on dependent and independent. Dependent is what it depends on. And also we talk about how to find a relationship rule. Sometimes we're adding, subtracting, multiplying, or dividing.